Over the last several decades, water agencies throughout the United States and other countries have found that under certain conditions, pre-stressed concrete cylinder pipelines, or PCCP, may have a reduced service life and elevated risk of failure compared to other types of pipe. PCCP failures can be catastrophic and can occur without forewarning, compromising system reliability and resulting in significant costs due to interruption of service, unplanned major repairs, and potential third-party damages. In response to this risk, Metropolitan initiated a comprehensive program in September 2011 to inspect, manage, and rehabilitate its 163 miles of PCCP lines. The second lower feeder is the first pipeline to be rehabilitated under this comprehensive program. PCCP is a composite pipe that consists of a steel cylinder and concrete core, which are wrapped with steel pre-stressing wires and then covered by a thin mortar coating. If a crack occurs in this outer coating, the wires may be exposed to moisture in the surrounding soil, leading to corrosion and breakage. In February 2013, electromagnetic inspections of the second lower feeder identified 19 PCCP segments that experienced an increase in pre-stressing wire breaks over the last several years. Approximately 900 feet of distressed PCCP was slated for repair within the city of Long Beach. Fabrication of the steel pipe liner is one of the first steps in PCCP replacement. The steel liner is designed as a standalone pipe which can accommodate full internal and external pressures on the line. Metropolitan's Laverne facilities have the capability of fabricating this steel pipe entirely in-house. Plate steel is first cut to size using a computer-controlled plasma torch. An overhead crane then loads the steel into a hydraulic rolling press. This press rolls and forms the steel into a cylindrical shape with the correct diameter. Once the steel has been rolled, special fittings and alignment blocks are welded in place. Using straps, the pipes are then collapsed into a smaller diameter and held in place with welded steel bars. The pipes are collapsed so they can be inserted into an existing segment of PCCP. Some steel pipe sections are welded together into their final shape with specialized fixtures and welding equipment and may include flanges and butt straps. Completed sections of pipe are then stored at the Laverne facility until they can be transported to the repair site. Before any construction activities begin, Metropolitan staff coordinates with local cities and municipalities for all necessary construction permits. External affairs staff also sends out notification letters to nearby residents and follows up with door-to-door visits to answer any of their questions or concerns. With construction set to begin, Metropolitan's operations staff closes valves to isolate and dewater the pipeline section. This can take 2 to 3 days. During that time, traffic control and construction site setup get underway and the contractor can begin to mobilize his equipment. Transportation of the steel pipe sections to the job site involves securing the proper hauling permits and complying with restrictions imposed by agencies along its route. Unloading the new pipe segments is performed carefully to avoid damage, as spare pipes are usually not readily available on projects of this magnitude. The location of the excavation is carefully selected so that its impact on the community is minimal. The location of trees, overhead lines, other underground utilities, and traffic needs are all considered. The boundaries of the excavation are first carefully surveyed and marked, the asphalt is saw cut and removed, and the excavation then begins. Steel shoring is used to prevent the sides of the excavation from collapsing. This repair on the second lower feeder occurred on a straight section of pipeline with a mild slope, so only one excavation site was needed. Once the PCCP is exposed, specialized saws are used to cut through the pipe. And the top portion of it is removed. The steel pipe can then be lowered into the pipeline. Once in place, a customized pipe carrier lifts the steel pipe up so it can be transported inside the PCCP section. The pipe carrier moves the steel pipe into the final repair location, and the straps that hold the steel pipe in a collapsed position are cut with a torch. The steel pipe springs open to its full diameter within the PCCP line. Tack welds hold the steel pipes in position while more sections are put into place. Welders then follow up with multiple passes to fully secure the steel pipe. Each 20-foot long section of steel pipe takes about 12 hours to weld. Once welding is complete, liquid penetrant dye and ultrasonic tests are performed on all weld seams. When all of the steel pipe sections are in place and welded, low-density concrete grout is pumped into the annular space between the steel pipe and the PCCP line through fittings installed in the pipe during fabrication. This grout helps to stabilize the pipe and protect it from corrosion. To further guard against corrosion, a concrete mortar lining is then applied to the inside of the steel pipe. On the second lower feeder job, approximately 100 feet of steel pipe liner was installed per day. With the steel pipe installed, workers then clean and disinfect the pipeline. The pipe can then be closed up and operations can begin refilling it with water. This can take up to 24 hours before water quality tests are then performed. While these tests are underway, the excavated area around the exposed steel liner is encased with concrete and the area is backfilled. New asphalt is placed and the street is returned to service. For the replacement of the 900-foot-long reach, this pipeline was shut down for a total of 31 days. The second lower feeder is now ready to reliably and safely deliver drinking water once again to Metropolitan's member agencies.